Hello all, welcome back to my channel. Today I am going to explain about components of the system which are necessary for proper functioning of an embedded system. So, some of the components of an embedded system are reset circuit, brownout protection circuit, oscillator unit, real-time clock and watchdog timer. So, let's first discuss about the reset circuit. It is a circuit that provides a regulated voltage to microcontroller with application of power. It is responsible for generating resetting signals whenever power is applied to a given electrical device. Thus, we can determine the state in which the device always starts operating. The reset signal brings internal registers and different hardware systems of controller to a known state and resets it. That means it resets the microcontroller whenever it starts executing. That means it resets the microcontroller and the microcontroller starts executing from 00000 address. The reset signal can be active high or active low. Some microprocessors or controllers have built-in reset circuit and those do not require external circuits. But few are there which are not having built-in circuits, so they need external reset circuits. The signal from the reset circuit will be applied at power on for such devices. Figure shows passive reset circuit for active high and active low configurations. The pulse width of the reset signal can be changed by changing the values of resistors and capacitors. You can look at in the diagram, you are having a resistor and capacitor. By changing the value of these, the width of the reset signal can be changed. Thus, the reset circuit resets if the controller enters the non-executing state. Next, let's move to brownout protection circuit. It is a circuit which prevents the processor or the controller from unexpected program execution behavior when the supply voltage falls below specified voltage. Now, assume we have a processor which is powered by battery, and as we all know, the battery voltage will be dropping. So, the supply voltage to the processor starts to drop, and if this voltage falls below the threshold voltage, then the processor behavior may not be predictable. That means it may lead to data corruption. So, in order to avoid this, brownout circuit is needed which provides protection to the processor. Look at the brownout protection circuit. It contains Zener diode, transistor and different resistors. You can look at, you are having R1, R2 are the resistors, DZ is the Zener diode, you are having a transistor Q, right? R3 is one more resistor which is used. We are having supply voltage which is VCC. We have voltage across emitter and the base called as VBE. We are having voltage across the Zener diode which is shown as VZ. Now, when the supply voltage is VCC and if it is greater than the sum of VBE and VZ, that is voltage across Zener diode and voltage across base and emitter, if the sum of these two is less than VCC, then it conducts. That means transistor conducts. If VCC falls below VBE and VZ, then transistor stops conducting. Thus, brownout circuit holds processor or the controller in the reset state when the supply voltage is below the operating or threshold voltage until the supply voltage becomes greater. These brownout circuits may be inbuilt or they may be connected externally. Now, let's move to the third type called as oscillator unit. Yes, what is meant by oscillator then? As we all know, it is an electronic circuit which produces periodic oscillating electronic signals. It is producing some type of signals called as electronic signals which are periodic and oscillating. It is made up of digital combinational and sequential circuits. So, the performance of a processor or controller depends on the speed of execution of a program. Now, the execution of the program depends on the instruction execution. This speed of execution of instruction directly depends on the clock signal, and this clock signal is now generated by the oscillator unit of the embedded system. The clock frequency decides the speed of operation, but is this clock frequency be increased to any value? No. Why? Because power consumption increases with the increase in the clock frequency. Hence, it has a upper threshold value. Some processors or controllers may have built-in oscillator unit, and these require the external resonator for generating clock signals. But some processor and controllers are there which are not having built-in oscillator unit, so they need this unit to be connected externally. The quartz crystal oscillator are available as external oscillators to be connected to such processors or controllers. So, all this is about the oscillator unit. Next, moving to real-time clock. It is a component which is responsible for keeping track of time. It provides timing reference, that is timing, which is nothing but date, month, year, etc. These are available in the form of ICs from different manufacturers. It functions even in the absence of power. Why? Because it contains backup battery cell. Timing reference is essential for synchronizing the operation of OS kernel. This kernel interrupts the processor when real-time clock reaches a specified value. Thus, real-time clock is necessary for an embedded device. Next, let's move to next timer called as watch down timer. You can look at the circuit. In Windows systems, assume in any Windows system, if any application hangs up, then what we'll do? We'll be just pressing Ctrl plus Alt plus Delete. In order to come out of the situation, we are pressing Ctrl Alt Delete. But can it be done in any embedded system? If embedded system hangs up, can it be done by using Alt Ctrl Delete? No. Then what is to be done? The answer is watchdog timer. The watchdog timer will be monitoring if the embedded system hangs out. Hence, we need watchdog timer. So, watchdog timer is a timer for monitoring the firmware, that is software execution. Watchdog may be up counting or it may be down counting. The timer increments or decrements the counter with each pulse and generates reset signal to reset the processor. See, down counting watchdog goes on decrementing at when it reaches 0, it sends a reset signal. And what about up counting? It's nothing but counting up. So, watchdog goes on incrementing up, and when it reaches the desired value, it generates the reset signal. Okay, now see, if the embedded system does not complete execution before the expiry of the time, that means it will have some stimulated time given to it, and within that timing the embedded system has to perform its operation. If the embedded system hangs up, then what? See, what the watchdog timer will do? It generates the reset signal upon the time expiry. Thus, the situation will be overcome. In modern systems, instead of resetting the system, the watchdog timer will be sending an interrupt signal. This watchdog can be inbuilt or it can be externally connected as discussed with the other components. So, all these are the components which are necessary for the embedded system. Thank you.